Light is supposed to travel at 300 million meters per second. But if light is so fast, how did anyone figure out that it even had a speed at all? I mean, I light a room and I see everything in it simultaneously. My reflection in the mirror matches my movements without any lag. Same with my shadow. Couldn't light just be instantaneous? And for most of recorded history, that's what scholars believed. But could you even tell whether light speed was infinite or just really, really fast? Galileo thought he could. He measured the time it took for the light of an uncovered lantern to travel from a distant hill. But either light was instantaneous or it was too fast to measure. Galileo couldn't tell. And Galileo didn't know it, but there's no way his experiment could have worked. Even if he'd used lanterns on mountains hundreds of miles away, the light would cross that distance in a tiny fraction of a second. Any further, and the lantern would disappear over the curve of the Earth. After Galileo, most European scholars just assumed that light was infinitely fast. And even if it wasn't, with all of those constraints, how would you even be able to tell? 38 years later, a Danish astronomer named Ole Rømer was not thinking about the speed of light at all. Instead, he was trying to figure out how to help sailors keep track of time at sea. This was tricky because the pendulum clocks of the day got messed up on a ship as it rocked in the waves. Rømer thought that he could use Jupiter's closest moon, Io, as a kind of clock in the sky. It was easy to see through a telescope, and it went around Jupiter quickly, like in less than 2 days. And like all orbiting objects, the time it took to orbit was always exactly the same. Perfect for telling time. Except that it wasn't. After tracking Io's orbits around Jupiter for many months, Rømer noticed something really weird. Its orbit seemed to start incrementally later for about 6 months, and then incrementally earlier for the next few. Over the course of a year, the overall differences amounted to only a few dozen minutes, but still, that should not happen. Rømer deduced that whatever was going on, it must have had something to do more with the Earth than it did with Jupiter and Io, because the discrepancy matched up with Earth's movements. The earlier orbits only happened when Earth was closer to Io and Jupiter, and the later ones when Earth was farther away. This made no sense, unless light itself actually did take time to travel through space. If it did, then the light from Io and Jupiter could arrive at Earth a few minutes earlier when it was along this part of its orbit, and a few minutes later when it was along this part. Those few dozen minutes of difference must be the length of time it took for light to travel from one side of Earth's orbit to another. Calculations of the speed of light based off of Rømer's data weren't all that accurate, but they did show one thing. Light might be crazy fast, but not infinitely fast. It had a speed, just not one that you could notice until you stepped back to an absolutely monumental scale.